Welcome to lesson 29, operations with functions. In our last lesson, we found when the functions were equal to each other. Now we're going to accurately substitute for any operation. Addition, subtraction, and multiplication are the ones we're going to see today. And we're going to substitute both functions using a parenthesis, so please watch how I'm doing that part. When we're adding, we're going to make sure that we distribute a positive 1 for that second set that's in a parentheses and combine like terms. When we're subtracting, we're going to distribute a negative 1 into that second set. So I want you to watch what that means if you can't visualize it right now. And when we multiply, we're going to distribute constants in that parentheses. All right, so let's jump into the first one, which is addition. So we're given the function f of x is equal to 3x plus 4 and g of x is equal to negative x plus 2. Find the value of j of x, which is f of x plus g of x. Okay, so I'm going to write that down. J of x is equal to f of x plus g of x. So j of x is going to be the term we're going to write a lot. Let's substitute for f of x, which is 3x plus 4. Notice that one is not in parentheses. Plus, and I'm going to put all of g of x into parentheses. Negative x plus 2. And I'm going to put in a 1 there in the front. And I'm going to do that on purpose so that I can distribute that. So let's move to the next part. Let's do the distribution. So when I distribute, negative x times 1 is going to be a negative x. And positive 1 times positive 2 is just positive 2. All right, and now I can write the rest. 3 of x plus 4 minus x plus 2. There we have it. All right, now all I'm going to do, so you have to note, I distributed. Now I'm just going to combine terms. That's it. So what do you see? I like using my highlighter. Here are my x's. Let me use red. Here are my constants. Okay? You can now do this in your head. 3x's minus 1x is 2x. 4 plus 2 is 6. And I can't simplify any more than that, so j of x is equal to 2x plus 6. Hit pause and jot this down into your notes. Let's do a subtraction one. Given the function f of x is equal to 3x plus 4 and g of x is negative x plus 2, so same expressions. Now we want to find n of x, which is f of x minus g of x. All right, so we're going to do the same thing. We're going to substitute for f of x, which is 3x plus 4 minus negative x plus 2. And I'm going to put my 1 there so I can distribute. All right, let's distribute. Negative 1 times negative x is just a positive x. And negative 1 times 2 is minus 2. Okay, now I can write the rest. And I'm not forgetting that was a positive, so I should have put plus x in the very beginning. All right, and then I do the same thing as before. I'm going to combine like terms, so just look for them. And then just combine them. 3 plus another x is 4 x's, and 4 minus 2 is 2, positive 2. And that's it. Hit pause and jot this down into your notes. Your answer, n of x, is equal to 4x plus 2. And now for our last one, which is multiplication. Okay, so given the function f of x is equal to 3x plus 4 and g of x is equal to negative x plus 2, so same terms. Find the value for j of x, which is f of x times g of x. Okay. So I'm going to do f of x times g of x. And I'm going to put my terms in. And this I want to put in parentheses. So 3x plus 4 times negative x plus 2. And this is where you got some options again, because you got binomials times binomials, which we've done before. So you can either FOIL or you can use the array method. So let's say you want to use FOIL. Your first numbers are 3 of x times a negative x. So that would be negative. Let me actually write that down so you can see what I did for the first numbers. 3 of x times a negative x, which gives us negative 3x squared. Let's go to our outside numbers, which are 3 of x times 2, which gives us 6 of x. Our inner numbers, 4 times negative x, negative 4x. And the last numbers, 4 times 2, which gives us 8. All right, so now let's rewrite it. J of x is equal to negative 3x squared plus 6x minus 4x plus 8. Look for your, here we go, our like terms. And we're going to simplify them. 6 minus 4 is 2. So J of x is equal to negative 3 of x squared plus 2x plus 8. Now, if you wanted to see it as an array, which is my personal favorite, but everyone has their own preference. You do what feels most comfortable to you. If you love FOIL, go FOIL. But you could have done the same thing by just putting your terms here on the outside. And you're still multiplying. So it's still the same. It's the same math, just in the boxes. So you're still doing your first numbers in this box. It is still FOIL. So you're still going to get 3x squared, and your outer numbers, 6x. 4 times negative x is negative 4x, and here's your 8. It is still FOIL, even though it's just written in an array. It is just another representation, so whichever one makes the most sense to you to use, just go with it, and you'd have the exact same thing. You'd still see which are your like terms, and you're going to end up with your same answer. All right, and that's it for today, Math Marbles. Hit pause and jot this one down, and that's what you're going to practice. You're going to do all these different operations using your methods. So hit pause, jot this down. All right, before we end the video, I want to give you 2 opportunities to do some practice on your own. So here's the first set. You have one where f of x is being added to g of x and one where it's being subtracted. So let's start with the addition first. I'm just going to start setting it up for you. Here's your h of x is equal to f of x plus g of x. Hit pause and see if we come up with the same answer at the end. All right, here's your final answer. Check to see if you got h of x is equal to negative x plus 8. As I'm looking through my work, notice I did distribute my negative 1 to get negative 2x plus 3, and then I combined my like terms to get negative x plus 8. All right, let's try with the second one with subtraction. Again, I'm just setting it up for you. J of x is equal to f of x minus g of x. Do not forget to distribute that negative 1. Hit pause, solve the problem, and see if we have the same solutions at the end. All right, check to see that you got the same answer. I did. J of x is equal to 3x plus 2. Make sure that in your work you've distributed the positive 1 because this is subtraction, and that you ended up with the correct term 2x minus 3, and then combined like terms. If you have something different, now's the time to change it. Try and see where your mistake was and if you can correct it. If you're still really unsure, this is where you ask for that feedback. If you can't follow along and find out where the mistake was, or go back and look at my example on subtracting. We have one more together, and this one is with multiplying. So given the constant k of x is equal to negative 3 and the linear function m of x is equal to 2x minus 11, find the linear function for n of x is equal to k of x plus m of x. So all I'm going to do, this was a lot of words, but all we're doing, again, is substituting for k of x, which is -3, times m of x, which is 2x minus 11. All right, hit pause and see if we have the same answer at the end. The reveal is coming in 3, 2, and 1. Okay, n of x is equal to -6x plus 33. This was a simple distribution. It was just a monomial times a binomial. All right, and that's it for today's lesson. I hope you feel really confident. So again, your criteria for success was to, for all operations, accurately substitute both functions using parentheses. If you are adding, please remember to distribute a +1. If you're subtracting, distribute a -1. And when multiplying, distribute that constant into the parentheses. And if you are doing a binomial times another binomial, you can use FOIL. If you are doing a binomial times any polynomial, you could use your array method. That might be the easiest way to go. And if it's just a simple monomial times any polynomial, you can just distribute the way we did here. That's it for today's lesson. I hope this is starting to really click for you in this unit. I'm enjoying it a lot. I'll see you in the next lesson, Math Marvels. Take care.